Hi, welcome to our first lesson for 3.6, making connections, tools, and strategies for applying exponential models. Our success criteria: I can perform exponential regressions on the calculator, determine how well the regression model fits the data, and then make predictions using the regression equation. So notice this word regression is coming up a few times. That's basically another word for an equation. So when we're finding a regression, we're finding an equation that can fit a certain table of values or a certain data that's given. So that's what we're going to do in this lesson. We're gonna analyze data, and then we're going to come up with an equation for it, and then we want to see how well it fits, and we also want to use that equation to make predictions, maybe about the future for the data. So use it to find any missing information. All right, so here's our first example. Construct a model of exponential growth. So it says, are Canadians getting wealthier? Consider the average weekly earnings rounded to the nearest dollar for Canadians over a 5-year period. So way back in 2002, the average Canadian made 679 a week. And then the next year it went up to 688, and then 702, 725, 747. So given this information, we want to try to come up with an equation that will fit this. So I'm going to do this by hand. I'm actually not going to use the calculator to do this. There are videos that are uploaded in the class notebook that will show you how to use your graphing calculator, which will be very handy, and it's actually quite easy to do. So I definitely recommend watching those videos. But for this example, I'm just going to go ahead and do this kind of just using a regular calculator. So if you know exponential functions, they always have that pattern of repeating growth where we always multiply by something to get the next term. Okay, we multiply by a constant amount. So I want to figure out what these need to be multiplied by in order to get the next term. So in order to do that, I can actually set up some ratios. I can do 688 over 679, which I have right here. Okay, notice I always do the bottom one divided by the top one because I want to find out what I need to multiply to get the next term. So I've set up all these ratios, 7 over 2 over 688 and so forth. So I can just punch these into my calculator and get a value. The thing is, because this is real life data, these values aren't going to all be exact. Okay, they're all going to be pretty close to a certain number, but not exact. So what I've done is I've set up an Excel file, copying that information over. So you can see we have the year. I then inserted another column, column B, which is the time. So if 2002 is the start year, that's time 0, and the earnings were 679 for that one. Okay. Now what I like to do is I like to calculate that ratio. So I'm just going to type in ratio here. And then in here, I'm going to tell this, I'm going to give it an equation. I'm going to say, let it be equal to this cell divided by the one just above it. So those don't look like the divide. There it is. Okay, that divided by this cell here. And I can enter. And there's the ratio, about 1.01325. The cool thing about Excel is I can tell this thing to fill, and I can copy that pattern. And what it's going to do is it's going to automatically calculate each ratio for me. So it starts off at about 1.01, and then it's 1.02, 1.03. If you want to double check that this calculated right, you can just click on a cell, and it says it did C5 divided by C4. So that would be 725 over 702. I'm just going to delete this last one because there's no values for that, right? So we'll get rid of that one. Okay, I'm now going to highlight those, and I'm going to see if I can get this to calculate the average for me. Let's make this a bit bigger. So formulas, I think there is an average button. Here we have the sum, there's average. Okay, so 1.0204 is the average of all those values from 1.01325 all the way to 1.03034. So I'm going to go ahead, I'm going to steal that number because that's like the average ratio. So 1.024. So let's go ahead and put our solution in. Average ratio between successive terms is 1.02, and I just want to double check it again here, 1.024. Keep a few decimal places and that should be handy. So what does this have to do with the equation? Well, our general equation follows this form, right? And remember, B is always that constant ratio or that common ratio between the terms. And A is always our initial amount. So because we're talking about money, what I'm going to do is I'm going to write an equation, A, for the amount. And my initial amount that I start with is 679. That's at time 0. My base of the function is 1.024. And then my exponent can be t for time. Time is in years. Okay, notice this time up here always has to coincide or correspond with these values in here. So notice each value is given every year. So that means time must be in years. Okay. So when we calculate this ratio, 1.024, that's because we were dividing the amount between each year. So the exponent needs to be in years. Okay, so that is basically it. That's how we could do these kind of questions. Okay, so I'm just going to summarize real quick. So find the average of the common ratios. Find the average of the ratios between successive terms. Okay, and then I'll just say this is the B value. So this is the value of B. Okay, then I'll say determine the initial amount. Time 0. Okay, this is the value of A. Okay, the next thing you just need to do is make sure your exponent aligns with this situation, and then you'll be good to go. So what I kind of want to go over that a little bit too. So let's say in this table, if the years, instead of them going up by 1 year at a time, let's say they went up by every 2 years, then we would want to adjust this accordingly. Okay, so you might want to put like t over 2, depending on the situation. Okay, so that is part A. Part B, predict the average Canadian weekly earnings in 2021. So in 2021, which would be last year, time would have to be, remember we started in 2002? So to get to 2021, we'd have to add 19, right? 19 years would bring us all the way to 2021. So t would be equal to 19. So then we can calculate the amount in our equation. You could put in 19 up here. Let's see what we get. That's not Desmos. Here's Desmos. So 679 times 1.024 to the exponent 19. So according to this, Canadians should be making on average $1,065 $1,056.54 per week. Therefore, weekly earnings in 2021 should be close to $1,065.54. So you see how we just used our equation to make a prediction. Okay, last part. Predict when the average Canadian might expect to earn $1,000 per week. So now that means set A equal to 1,000. So we're going to have 1,000 equals 679 times 1.024 to the exponent t. Notice these questions always kind of come up. So where we set this equal to a number, the left side, and then we got to find the exponent. So what we like to do is just kind of simplify this a bit. So first step, divide out the 679, divide this by 679, and then we're going to get 1.47. Then we got 1.024 to the exponent t. So now we got to solve this. So you can try doing some trial and error for t. So try plugging in like 2 or 5 or 10 until you get something close to this. The other way is to graph this. So you can actually graph two equations and then find the intersection. So you can graph this first, the exponential part, and then graph a second equation, which is the left side, and then find the intersection point. So I'll say find x when the graphs intersect. And that's going to be your solution. Okay, that's a great way of solving these. So let's go ahead and do that. So we have 1.47, and then we have y equals that, sorry. And then in the next equation, we're going to have y equals, here's my exponential one, 1.024 to the exponent x. Okay, now we just want to see where they intersect. And it happens when x is 16.2. Okay, so this happens at 16.2. So I now want to convert that to years. So remember the years start in 2002. So 16.2 years after that. So we can say 16, we don't need the 0.2 part. We can say 16 plus 2002 equals 2018. So therefore, around 2018, weekly earnings are around $1,000. Okay. And that wraps up our first example. I'll see you guys in the next video.